In this lesson, we are going to learn about logarithms. We're going to learn how to define logarithmic functions and how they are related to exponential functions. Now, before we get into this lesson, many people are intimidated by the word logarithm. But there's not really a need to be intimidated because all a logarithm is an exponent. That's your definition. A logarithm is an exponent. Now commit this definition to memory because this definition will be the underlying principle that drives us through this entire lesson and the entire concept on logarithms. If you know this definition, then everything else should kind of fall into place. And this entire lesson, by the way, when we deal with logarithms, is all about pattern recognition. So for example, here we see on the left column what we're familiar with. We are familiar with exponential form of a function. Right here we have 2 to the third power, meaning 2 times 2 times 2, and that equals 8. 2 to the fourth power is 16. 2 to the 0 power would be 1. 2 to the negative first power is the same thing as 1 over 2 to the positive first power, which would be 1/2. Now, logarithmic form, all we're doing is we are writing this in a different way. Remember we said a logarithm is an exponent. So what we have, in order to convert, is we have a logarithm. Is means equals, so logarithm is going to be the equal sign, and then the exponent. So when you convert back and forth, if you remember the definition, then everything else should fall into place. So here we have the equal sign, exponent is going to be over here, and log goes on the left side. So we see all the exponents, the 3, the 4, the 0, the negative 1, that is on the right side of the logarithmic form. And then notice that the base in exponential form is a 2. We have 2 to some power for each of these. In logarithmic form, same thing. The base will also be 2. So we see here there's a 2, here's a 2, here's a 2, and here's a 2. So whatever the base is in exponential form, that is the base in logarithmic form. And then the only other number left over, so in this case, the 8, the 16, the 1, the 1/2, that is going to be the other number that you write right here. 8, 16, 1, and 1/2. So it's all about pattern recognition, and the pattern is based off the definition that a logarithm is an exponent. So the remainder of this lesson will be simply going back and forth between exponential form and logarithmic form. Here we want to write the following in exponential form. So we are given a logarithm, and we want to write this with exponents. Well, remember, it's all about pattern recognition. We said a logarithm is an exponent, right? So the 2 is going to be your exponent. And then the base for a logarithm will be the same as the base in exponential form. So the base here is 7. So the base when I rewrite this is also going to be 7. So in exponential form, we have this. The base 7 would be the same as the base here, which is 7. The exponent is 2, so we put that right there as your exponent. And then equals 2, and the other number that's left over goes on the right side. Okay, here's another example. Write this in exponential form. Remember, once again, a log is an exponent. Here we see the base is 7, so the base for this one would also be 7. So 7 to some power. Well, the exponent is going to be right here. A log is an exponent. The 1 is going to be your exponent. So we have 7 to the first power equals, and then the other 7 goes on the right side of the equation. Let's look at another one. Same thing, same concept. The base here is 10. So the base for exponential form would also be 10. A logarithm is an exponent. So this would be your exponent. So the negative 2 is your exponent. So we have 10 to the negative second power equals, and the 0.01 goes on the right side of the equation. So what we've just done right here is basically the entire lesson. So if you understand up to this point, you're pretty much good to go for the lesson, but I'm going to walk you through a bunch of other examples so that you get the hang of converting back and forth between different forms. So here we have log base 2 of 16 equals 4, and we want to write this in exponential form. Well, the base here is a 2, so the base when I rewrite this in exponential form would also be 2. A log is an exponent, so 4 is your exponent. So we have 2 to the 4th power equals this other number that's left over, which is the 16. Here's another example. Log base 4 of 16 equals 2. To write this in exponential form, the base here is 4, so the base when I rewrite would also be 4. The 2 would be your exponent, so we have 4 to the 2nd power equals 16. Here's another example. Here the base is a 7, so we have base 7, and then the 1/2 is your exponent. So we have 7 to the 1/2 power equals, and the square root of 7 goes over there. Here's another example. The base is 3, and the exponent is -3. So we have 3 to the -3rd power equals 1 over 27. Another example, here we're going to write this the other way, where we have it written in exponential form. We want to convert back into logarithmic form. So here the base is 8, so I write this as a log with a base of 8. A log is an exponent, so what it's equal to will be the exponent. So the exponent is going to be 0, which goes over there. And then the 1 goes right there. So what I have is going to be log base 8 of 1 equals 0. Another example, the base again is an 8. So we have log base 8. And a log is an exponent, so the exponent is going to be what it's equal to, which is going to be -1 over 3. And the 1/2 is going to go over here. So we have 8, log base 8 of 1/2 equals -1/3. Here's another example. The base is 6, so I write this as a log with a base of 6. A log is an exponent, so what it's equal to will be the exponent, which is the 3/2. And then the 6 square root of 6 goes right here. So we would say that we have log base 6 of 6 square root of 6 equals 3 over 2. Now we want to write this one back in logarithmic form. Here we have a 3, which is the base, so we have a log base 3. And then a log is an exponent, so what it's equal to will be the exponent, which is 3. And the 27 is going to go over there. So I have log base 3 of 27 equals 3. Here's another example. The base is 16, so I write this as log base 16. And then a log is an exponent, so what it's equal to will be the exponent, which is 3 over 2. And the 64 is going to go right there. So my solution would be log base 16 of 64 equals 3/2. Here we have 10 to the -1st power equals 0.1. The base here is a 10, so I write this as a log with a base of 10. A log is an exponent, so the exponent is what is equal to, and then the 0.1 goes right there. Here we have another one. The base is 81, so we have log, and then the base is 81. A log is an exponent, or it's equal to the exponent, and then 1 over 27 goes right there. Now what if you are told to simplify a logarithm, meaning we want to figure out what is this equal to? Well, what I can do is set this equal to x, because I don't know what it's equal to yet. And then from here, I'm right back to where I started. where the base is a 6. So I write this with the base 6. A log, here is the log, is, and then exponent is going to be the x. So the base is 6, your exponent is x. So we have 6 to the x power equals 36. So 6 to what power gives me 36? Well, that is going to be 2. So x would be 2, and that's my solution. If you had log base 2 of 16, and we wanted to know what is this equal to, well, I'll set it equal to x, and then do the same thing. The base is 2. A log is an exponent. This is going to be your exponent over here. So we have 2 to the x power equals 16. And 16 you could think of as 2 to the 4th. So the base is the same. Exponents must be equal. X must equal 4. So log base 2 of 16 must equal 4. Here's another one. Log base 5 of 25. We don't know what it's equal to. So we set it equal to x. And we figure out what is x going to be. Well, the base is 5, so I write it with a base of 5. X is going to be your exponent. So we have 5 to the x power equals 25. 25 is the same thing as 5 squared. So the base is the same. Exponents must be equal. X must equal 2. So log base 5 of 25 would have to equal 2. Here's another example. And we are told to simplify and try to figure out what is x equal to. Same thing, the base is a 2. Your exponent is going to be x. So we have 2 to the x power equals 8 square root of 2. Now the question is, how do we figure out what is x equal to in this case? Well, what we want to do is convert 8 and the square root of 2 as 2 to some power. So 8, you can think of 8 as 2 to the 3rd power. And this radical, remember, we can convert with exponents. So we have a 1 here, 2 to the 1st power. It's a square root, so it's going to be 1 over 2 as your exponent. And now the base is the same. They both have a 2. I can combine by adding your exponents. So 3 plus 1/2 would give you 3.5 or 7/2. So now the base is the same. Your exponents must be equal. So x must equal 7 over 2. So log base 2 of 8 square root of 2 would equal 7/2. Now here's an example that doesn't really follow what we've been talking about necessarily, but a property to know is that if you have 2 risen to a log power, so we have 2 to the log base 2 of 7 power, if this base 2 is the same as this base of 2, basically it's kind of cancels each other out, and I'm left with just the 7. So my solution here would be 7. Here's another example where the base is 4, and you raise it to the log base 4 of 12 power. So the base is 4, and the base here is 4. Those kind of undo each other, and I'm left with just the 12 as my solution. We also need to know how to solve logarithmic equations. And it's exactly the same thing that we've been doing, where now we have log base x of 16 equals 4. So our objective is to solve for x. And to do that, we can just think through the pattern, where the base is x. So when I rewrite this in exponential form, I can write this with the base of x as well. A log is an exponent, so the 4 is going to be your exponent. So we have x to the 4th power equals 16. Well, I can then solve for x by taking the 4th root of both sides, which would undo the 4th power. So the question is, what is the 4th root of 16? Or what to the 4th power gives me 16? Well, that's going to be 2, because 2 to the 4th power is 16. Now, as we conclude this lesson, there are 4 properties to know of logarithms. And here, if we have the base of b, and then this number is the same, so b and b, it could be 4 and a 4 or 5 and a 5, and this number here is raised to some power, then my solution would just be the power that is risen to. So for example, if we had log base 5 of 5 to the 6th power, my solution would just be 6. If the base and this number are the same, my solution is going to be the exponent. One more like that, if we had log base 10 of 10 to the 5th power, the base 10 and this number is 10, would mean that your solution is going to be the exponent, which is the 5. Okay, so that's your first property. Second property is if this number and this number are the same, your solution is going to be 1. Which makes sense, right? If we have log base 6 of 6, and we're told what is this equal to? Well, to solve a logarithm, the base is 6, so when I write in exponential form, the base would also be 6. 6 to some power, this is your exponent, is going to equal this other number of 6. Well, 6 to what power gives me 6? Well, that's going to be 1. So no matter what the numbers are, it could be a 10 and a 10, it could be 8 and 8, 6 and 6. If those are the same numbers, your solution would just be 1. This third property says that if you have any base, and this number here is a 1, that will always equal 0. And the reason is the same as it was for the second one. Because if you were to take, let's say, log base 10 of 1, and you want to know what is this equal to? Well, it's equal to something, so we'll call that x. And then we say 10, the base is 10, to the x power, because that's your exponent, is going to equal to this other number, the 1. So 10 to what power gives me 1? Well, 10 to the 0 power would give you 1. Anything to the 0 power would always give you 1. So my solution would be 0, and that is the reason. And the fourth property is as we just discussed, and that says that if this base is the same and you want to raise it to the logarithmic power, and this base is the same, it's down here, then your solution would be whatever this is equal to. So n would be my solution. So as we said, if we had 4 raised to the log base 4 of, let's say, 12, then my solution would just be 12, because the base and this base are the same. My answer is going to be that number. And that concludes our lesson for today. We will see you next time.